Hello, my name is ADELINA ALEKSIEVA-PETROVA, and together with my colleague NEVENA SHULEVA, we would like to present our research. So I will want to present our paper, GIS application for forest territories, providing water ecosystem services. The research leading to these results received funding from the Bulgaria Science Fund. A project assessment of the water ecosystem service provided by forest area with water protection function in Bulgaria. Uh, in Bulgaria, the forests are divided into two main groups, depending on their purpose. So the first group is the forest with the economic importance, and the second is forest with the special purpose. The protected forests are a subgroup of the forest with the special purpose, where the forest with water protection functions belongs to. The sanitary protection zones around water sources and drinking and domestic water supply facilities are defined and conditioned and procedure for their study, design, improvement and exploitation are established by the regulation of the Ministry of the Environment and Water and the Ministry of the Health and the Ministry of the Regional Development and Public Works. The sanitary protection zone consists of the three belts. So the first one is the inner belt, which includes the territory around the water source, which is highly secure and strictly guarded against human activities that may damage the water used. The second one is the middle belt, which protects the water source from pollutions by chemical, biological, and repeatedly designed substance, and from activities leading to the reduction of degradations of the quality of the water resource. And the third one is the outer belt. This is the third one, includes additional protection of the water source against pollutions from slowly degrading and difficult to degrade substance. So the forests in Bulgaria and their water protection function in particular are an important part of valuing the water ecosystem services, which provides economic value. The diversity of the data source and the amount of the data to be processed completes the process of the assigning water ecosystem service data provided by forest. Therefore, it is of particular importance to be able to summarize visualization and filtering this data in appropriate way in order to be able to make the necessary decisions. The main objective of the paper is to integrate spatial data on sanitary protection zones and a database on forest in Bulgaria into repository, and to design and create GIS application which supports the visualization and analysis of this data using different views. In order to achieve these goals, the following problems or research problems are defined for solutions. So the first is to propose a method for data processing and data aggregation into a repository, to propose a GIS architecture for data processing and visualization, and to implement an experimental prototype to validate the proposed data processing method and architecture. So, ecosystem services are the benefits that people receive from nature, and therefore the value of these services is important changes. Um, As we said, the heterogeneity of the data which is being used for services assessments is also challenging. So a method is proposed to process spatial data for different zones and a database of forests in Bulgaria. The spatial data from these three zones I provided as three ASRIF-shaped files for each of three categories. The second source of data, these are Excel tables that contains information about the regions, districts, forest group, year class, the sanitary protected zones, area, and other fields. So we propose the method which has two main stages. The first is the initial data processing, and, and the second one is creation of PostgreSQL and PostGIS database based on this initial data processing. So in the first stage is implemented, the first stage is implemented in two steps. The initial processing of the source data and the database design on forests in protecting zones. In the initial processes, the processing of the source data, topological processing of the spatial data for the different zones was performed. Overlaps were found both between individual layers and between polygons, including in each individual layers. The topical rules must not overlap with to detect overlaps between layers and must not overlap to detect overlaps between the polygons within a layer were used. The following algorithm was applied to remove detected overlaps. So in the ArcGIS environment, territories from zones, second and third zones, that fell with first belt were sequentially removed, and subsequently territories from the third that fell within the second were removed. Overlaps within each individual layers were removed. Three general layers were created for the individual zones categories. And the next sections were created between the generalized layer for the sanitary protected zones, as well as a special layer including a boundaries of the municipalities in the country. So the database of the forest in the sanitary protected zones was created, uh, and it is use some steps. That the first is the cross section between the national forest layer and layer obtaining as a result of the point 3 and 4 of the proposed algorithm using insert sex procedures were created. After that, the selection of the database record containing information of the taxonomic characteristics of the subparts, falling into these three categories, zones categories. So these data, according to the structure of the forest database, are contained in one table, which is called wood type. So three tables were created corresponding to these three sanitary protect zones categories, which has the main information from forest database of the national parks. And the last that requires that data contained in the table obtained from the common forest database were adding the six tables. So the second stage, it includes the data processing. It's create a database in the PostgreSQL and Postgres environment, which this database includes source, special, rare, and data in form of the three tables that contains the boundaries of the sanitary protected zones from belt 1, 2, and 3. So there is has some structure which contains the service identifier, site identifier according to the ministry, and the environment and the water of Bulgarian database, permit number account, and site name according to this database. So in order to visualize all these database, open source software products is used, uh, and it designs a web GIS application. So this slides shows the architecture of the design web GIS application. Now, as you see, three main layers have been implemented: database layer, server layer, and a presentation layer. PostgreSQL has been used as a database management system along with its special data exception PostGIS. The server layers contains two servers. One is the Geo server, which is working with the special data, and the Apache Tomcat, which is working with the database with the information of the sanitary protected zones. So Apache Tomcat was used for data filtering of the region, distriction, forest group, year classes, the sanitary protected zones and area. A GeoServer was used to publish the special data in the web environment, and the Map Store application was used as the end user interface, which is in the presentation layer. So the two software application, GeoServer and Map Store, are product of the Italian company Geo Solutions. In order to visualize the data, a dashboard in the Map Store was created to provide a set of information suitable collected to show aggregation data in one view. So geospatial data displayed in the map can be placed side by side to related attributes like table, charts, and other, with the aim to connect different kinds of information, show statistic details, and textual description related to the specific context. So all user can visualize and interact with publishing the dashboard, but only user who wants to edit can add, arrange, resize, or delete all the widgets inside the dashboard. Uh, so in the map, you see uh, the specific information which is extracted from the database, which includes the service identificator, site identificator, according the Ministry of the Environment and the Water Bulgaria database, permit number, site number, uh, and also you see the area of this of the selected belts of the selected zone. So here is you see the area in the square meters, and they are very useful information. So The system provides a function which helps user to select which type of widget they want and then add to the dashboard by selecting one of the items in the list. So there are the widgets as chart, text, table, container, and map. So the process includes the following three steps: select the vector layer, configuration the data, and saving and editing to dashboard. So, for example, the chart widgets is used to um, show an aggregation data, and the user can choose which chart type, such as pie, line, or bar chart, is want to use it. So, in results, it is generate the new interactive map to the dashboards, which add these widgets to them. So the implemented GIS-based systems fulfills its intended purpose, is user-friendly, and integrates the data from sources to represent the water ecosystem services in Bulgaria. So in these figures, you see the screenshot of the system, which filtering data from some specific sanitary protected zones with identifier, which is visualization on the map, and calculating and display the average value of age, health, completeness, growth, total area, and total forest stocks. So I would like to give floor to my colleague, um, the NEVENA SHULEVA, which will represent some discussions and results.
Hello, ladies and gentlemen. System services was introduced in the early 1980s, but it has been in the last 20 years that it has attracted increased attention. Ecosystems and ecosystem services contribute to people's well-being. Therefore, the European Union has called on member states to map and assess the state of ecosystems and ecosystem services, quantify and assess the economic value of ecosystems and ecosystem services, and integrate ecosystem services into their national policies. Our research focuses on water-related ecosystem services provided by forest ecosystems. Under Bulgarian legislation and the Forestry Act of 2011 in particular, these ecosystem services are one of the 9 paid services obtained from forest territories, which have to be paid for by users, and the received funds are to be distributed among the owners of these forest territories, namely territorial units of state forest and hunting holdings, municipalities, etc. An assessment methodology and payment mechanism for the paid services obtained from forest territories in Bulgaria is yet to be developed and adopted. Sanitary protection zones, or the so-called water protection zones, intended for drinking and domestic water supply according to the EU Water Framework Directive and the Water Law, are defined around water sources and facilities for drinking and domestic water supply from surface and groundwater. According to information provided by the Ministry of Environment and Water in Bulgaria, there are 7,484 water intake facilities from which water is drawn for drinking and household purposes. Each sanitary protection zone is divided into 3 belts according to an adopted methodology, and the forests that fall into them have water conservation and water production regulating functions. In this context, forest territories falling within sanitary protection zones are considered to be a resource known as natural capital, whose product is water related ecosystem services and not wood, In order to quantify the value of water-related ecosystem services, it is necessary to determine the economic value of the forest production capital. This involves the difficult task of studying the territorial distribution and characteristics of forest territories falling within the scope of sanitary protection zones in Bulgaria. Now, I would like to give you an overview of the results obtained from the implementation of this task. Let's have a look at what we did and how we did it. First, we created generalized layers for sanitary protection zone belts 1, 2, and 3 using the dissolve feature. Secondly, we created intersections between the generalized sanitary protection zone layers and the spatial layer, integrating the borders of the municipalities in the country using the intersect feature. Then we created intersections between the national forest layer and the layers generated as a result of the previous two steps using the intersect feature. A database containing information on the forest mensuration characteristics of subdivisions or parts thereof falling within the three sanitary protection zone belts was also created. Finally, we created a geographic information system of forest territories within sanitary protection zones in Bulgaria. The source database used consists of spatial data on each of the three belts within the sanitary protection zones and the database of information on forests in the Republic of Bulgaria, valid as of December 2019. The created database enables the generation of detailed reports on forest territories within sanitary protection zones at regional, district, and municipal levels. Bulgaria is divided into 6 economic regions: northeastern, north central, northwestern, southwestern, south central, and southeastern. Each of these regions consists of 5 or 6 districts. All 28 districts are divided into a total of 266 municipalities. The generated fact sheets contain data on area distribution, stock and growth per 1 hectare of forest land by forest groups and main tree species. On the slide, you can see a fact sheet for Sofia City and Sofia District. The table contains data on the distribution of forest territories by area, forest types, and age classes in the three sanitary protection zone belts, and the graph contains data on growth by age classes in the three sanitary protection zone belts. On the next slide, you can see a fact sheet of data at municipal level. It contains data on forest territories within the sanitary protection zones of Samokov municipality. Finally, in conclusion, I would like to point out that the results presented on the assessment of the territorial distribution and characteristics of forest territories within sanitary protection zones around water sources for drinking and domestic water supply in Bulgaria are going to be used to quantify the values of the forest-related natural capital and water-related ecosystem services at municipal level. This is also the next stage in our research project.
For more details, you can visit the site of the project where you can see the more information of the different belts in the map and also the statistics for each of them. Thank you for your attentions, and if you have any questions and feedbacks, please write to our emails, which you can see on the slide. Thank you once again and have a nice day.